All right, let's see how this goes. This is for class 21, and I'm going to try to demonstrate how to analyze CAMs using Excel and using SolidWorks. So this first video is going to be walking through a tutorial in how to use Excel to set it up and do the CAM analysis. And I wrote this a while back. So I'm going to be trying to follow it, and hopefully this won't be take too long and be too disjointed. Sort of taking a risk. So anyway, I'm going to start up with a fresh Excel spreadsheet, just like that you would if you were following along in the tutorial. And we're going to start out by opening this, and I'm going to create some labels. Where I'm going to make time. Let me make this a little bigger so that you can see it a little bit better. No reason to have that small. Time, I'll go theta. Let's go insert symbol, and you might have to search through these. And you can see, like, if you just go to normal text, it's about 1/3 maybe of the way down, and you would find where the Greek letters are. And you get theta. We just put them into there. And for C, I want to have S, and then I want V and A and J, right? So these are the things that we're going to try to get, and I'll center all of them. And for time now, I think I will go for theta right here, and I decided to make it enter 5, 10. I decided to go increments of 5 degrees. Let's see. So 5, 10, and then I'm suggesting that we drag this down, and I'm saying to go all the way down to B74. So I've already figured out how far to go down to get 360 degrees. And it worked. Look at that. It was way to go for me 5 years ago. And do I want those centered? Nah, I don't care. Leave them on that. And so for, and I'm going to disregard the statement in class about adding rows in between 90 and there, okay, because they cause more trouble than it solves. In column A, so I probably should get rid of that instruction, but I'm going to leave it in there just for posterity. Column A, I'm going to enter the formula B2 divided by 360 and double click right there. And why are we doing that? I don't know. So we're going to equal B2 divided by 360. So I guess what we're saying right here is we're getting like a time, or a virtual time, really, and it's just making it like if we were going to have 1 revolution per second. I guess that's what that is. 1 revolution per second. We could also perhaps maybe make an additional cell and divide an angle, but also we have to convert for radians. But we're doing this by degrees, so that's fine. So we're made really this a non-dimensional time, really. And okay, double click, and Laura says the value of A74 should be 1, equivalent to distributing the time. And then in column C, right here for the position here, we're going to go for cells C2 to C19 for a range of 0 to 85 degrees. We're going to make zeros. So I think I can just go from here to 19. These are all zeros right here. All right, and so now in this cell, I'm going to make using the formula S is equal to M theta plus B. So a linear rise. We're going to where M is going to be 1 divided by 90, and B is going to be -1. If you could think of it there, we're going to I'll write out this equation right here. So I guess I didn't bother to tell them what that was. So it's going to be equal to this right here divided by 90, and then -1. Is that right? Yeah, okay. And so I'm going to make this go all the way up to maybe 175. All right, and then here, let's see if I go one more, what happens? Yep, I get to 1. That's good. All right. And then I'm going to enter 1 right here, and I'm going to drag it all the way down to probably to 265. And now I'm going to enter in equals, and then I'm going to go negative this divided by 90. And then is it plus 1? Oh no, b is going to be equal to 4. Okay, I know why I did that. Yeah, so it's going to be plus 4. Yes, it is. And then I drag this all the way down to 360. Yes, I do. Okay. Well, that's an interesting thing. I got to remember why I did that. Interesting. I'm just following directions right now, and that's not very smart. So if we were going to maybe figure out why we picked out 4, it's probably going to be because of the angle. I'm doing mx plus b, right? So what I want to do is I want to get rid of all this. I don't even know what any of that is right there. I'm probably, I want to draw. I want to draw. Give me a pencil. Give me a thick line. All right. So I'm doing mx plus b. I have a slope of 1 for that first. And I guess, yeah, that's what I'm doing right there, is I've broken that up right there. So that's why this is going to be negative 1. And so this is going to be 90 degrees. And this is going to be 180 degrees. And then I'm going to come over to here. And this is going to be my 270. And here's going to be my 360. And what I've done is I've taken with a negative slope so that I've been able to end up with my points right there. So this is what I meant to do, right, was to go up here, up there, down here, and then down there. So, and in the cell, let's see, okay, now I want to highlight these cells, B2 to C74, and go in and hit a scatter. Okay, so I'm going to come back into this, and I'm going to go, I guess I'm doing it by, yeah. And I want to insert a scatter plot with straight lines. I don't quite like that, but I guess I'll do it with straight lines. Yeah. Okay. And then I started getting all like demanding here, and I tell people to get rid of these lines. Get rid of the chart table. Do I say get rid of the chart table? Let's see. I say we want to get rid of the, I said to get rid of the legend. I don't know if this one has a default legend or not, but we can. Let's get rid of the title right here. And then we want to format the chart area. And I usually tell people to get rid of the border, no line, because there's no reason to have that border right there. And I'm going to drag this back up to the top. My secret to not having to drag it up is go Control X and then back up here, Control V. And I want to start manipulating some things. And I want, and this is going to be like make it easier for me later on. I grab a hold of these axes. Let's see. Follow the format the axes. In the axis options, enter, so these are axis options. We're going to go from 0 to 360. That's going to be all messed up because it wants to go increments of 50. So let's go increments. What do we decide to go? 90 is the major unit. That's good enough right there. I guess so. Sure. It doesn't really matter. And oh, you know what I did? I decided to leave in. I accidentally deleted this. So in my directions, I also want to go. So I do want grid lines in the vertical direction, right? So it'll go that'll make it look good. So okay, so I already selected no line for the border. I'm at 14. I go axis titles. So I decided to add in axis titles. We want horizontal with the title below. I want vertical right here, and grid lines. I decided to only go. Okay, I hate grid lines in only one direction, but they're appropriate in this case. And then I think I label this as simply S. And then I think I label this as theta. And I think I can go and hit degrees, symbols, symbol here, and hit theta. And sure enough, and we can write degrees. Just as a reminder, okay. And then, so it will be out of the way later. And I decided to put this over here. Somewhere over there, right? So I want to try to size this thing so it's going to be useful to me, right? So because I want this, I'm going to recopy this so I don't have to do it each and every time, right? So I'm going to try to get this to be a size that's nice. A lot of times we want to like maybe size it 1-to-1 in a Word document, and for me, let's see, that's not really showing it right here. I could like pick this guy out right here. I could see that the Word document, like 6.5 doesn't look too bad to fit, but maybe make it 6 right here. So that come up to here and go to Format, and maybe make this, right, it's already 6.4. 6 is a nice shape. And its overall dimensions, maybe make this 2. That's not bad. I might want to make it a little smaller, but I also might want to constrain these, but I haven't said anything on there. Now what we want to do is I want to hit, the graph will look like this, and to save some time, select this graph and hit Control-C, and hit Control-V, all right, and do it a couple times. Do it 3 times, Control-V and Control-V. Well, not V. And what we could do, by the way, is select all of these. And are they in line with each other? They're not. We can Format, and we can go Align to the left, right? And while we're at it, we might want to group them. Sometimes it's better to group them together. I'm not going to right now, but we will later on, right? So, I am giving you some explicit directions, and I did the left align, and now we go to cell D here, D3, and I decide to D3. I decide to go equal to, and just like we've done before, right? So this is interesting that we're doing something we're differentiating this thing numerically, and I go SK1. So it's going to be +1 minus this one divided by this minus, oh, did I do T? I decided to go T. All right, so that one minus that one. Boom. Of course, all of those are going to be 0 right here, but we're going to catch up right there, right? So actually, I think I can go all the way down, right? And we might, yeah, we can give a decimal place. Not going to hurt anything, I think. So you can kind of see what we're doing, right? Right here, we could go ahead and make this into V, and then grab a hold of that, and then just shift him over 1. And look what he did. He's a square wave. And by the way, it's just pretty. To make this, what color did I say to make it? I think I kind of like green for velocity sometimes. I mean, not that it matters, but I kind of like green for velocity. I like red for acceleration because it seems like red is accelerating. Now I'm going to do the same thing, I believe, so I'm on thing 20 here, and I'm going to go to D3. Interesting that I decided to do that. I guess I can. It's not going to hurt anything. I really should go to this one, truth be told, and take this minus that and divide by this minus that, right? Boom. And then come down. And you might want to get rid of this last ones because they don't count for anything. And that doesn't count for anything either. So that's going to get all messed up. But that's all right. We could go to this column. And now let's drag him over 1, over 2. Boom. You can see how that slopes up right there. And well, I forgot to label this as A, and I'm going to change this guy's color to red. Boom, because red for acceleration. And then you get the idea of what we're going to do for the next one. And you know what? I don't mind making that right there. It doesn't really matter because these are all 0 right here. So I could just go. Technically speaking, though, you know, we want to see. I want to go parentheses. There's nothing really there into those cells, but I don't know. And now for this one is going to be our J. And we don't really have units because we just jumped up from 1 and so forth, but we could take a look. Boom, right? So that's what I get right here. I decided that I wanted to have units over here, so I set my units. I guess I decided to set this as well, I guess 5. I don't know. Well, let me think. I think I did say somewhere in here to change the limits from. So where did I end up changing the limits to? I went from 1.5. That's fine. 8. Yeah, I kind of changed it every time. I decided to, okay, but I didn't over here. I decided to set the limits of this from -100 to 100, right? So then it kind of looks like it's jumping off. And I did set the same thing over here, but I set this one to, what did I set this one to? Interesting. I sent it to 1,000, but why didn't it jump up that high in 1,000? Let me take a look at my previous slide right over here in this bad one. What is going on? What is the difference in here? I'm doing it by time, but for some reason what did I do? What did I do? Why is it different? That divided by that divided by that. All right. You know what? I think. Let me double check on something. Let me try this right here. Instead of this, let me move on to, so I didn't do the one ahead and the one behind thing. I did this, right? So it was the one that was right in line with it. Well, no, it doesn't like that. Yeah, so I did the one in front of it. Yes, right. Forward facing. And similarly, I brought this one down and that one down, right? So I should be able to come up to here, and then I put all those downwards right there. Okay, yeah, much higher slope. And then similarly here, instead of that one, instead of before and after, I did the one at it and then the one after it. And it still didn't really give me that really sharp jump. Let me pause. Already at the 20-minute. Okay, so I see what I did wrong. Okay, so I backed up to how I had it before, where I was doing it the before and the after. So I'm sorry if you're following this and I just made you go zigzaggy. But so these cells, I went ahead and did that, and then I made an exception for this cell and for this cell, right? And so these top cells right here, they're different from all the others but beneath them. The rest of them are the before and after. What I did wrong over here on the J is that I accidentally previously had it, so I was taking the difference with respect to theta. So you probably picked up on that, right? So that's dragged all the way down. So that's why I didn't get the magnitudes that I expected, and I did get rid of those last ones right there. So there's no problem there. And so now I get to this magnitude, and I decided I think it's negative 1,000 and 1,000. I'm just trying to show that it's going to infinity. It doesn't need to have to be all pointy, but you do see that it's coming up to positive infinity and come down to negative infinity as part of this, right? That the slope has come in there. Okay, so now I'm set up for this, and I decided to copy this. Well, I changed. First off, I renamed this to novice. And now I can copy it and move it so that it's after, and I could change it to that it's sophomore. And we'll modify the displacement function, and I will provide less guidance from this point forward. So for this, for the sophomore, we're going to come down and characterize by the equation of h over 2 times 1 minus the cosine of pi theta over b, where h for us is going to be 1. This is the rise function in cell C20, right? So in C20, we're going to come right here, and I have decided to enter this in for you to show you what I mean by it. So let's actually pull this guy over right here, right? So if we're coming through here, I think we have gotten to this point right here, and so let me grab all this and I'll show you a little trick. So I grab that piece of text right here, and if I want to bring it in here and see it, I can go to paste special and to paste it as an enhanced picture, and so you can actually see what the text looks like. Unfortunately, the fill things get in the way, so I usually have to do a solid fill and turn it to white. But now you can read what this thing has to say. So coming down here into C20, what I want to enter, I'm trying to enter in this equation, I'm pointing at the screen with my finger, of h over 2 times 1 minus the cosine of pi theta over beta. And then I've also entered this in for you. I decided theta is equal to beta in this case, because beta is the span of a particular thing. Yeah, of the span that we want to move over. I think that's correct. Yeah. So we end up going that it's going to be equal to 0.5, right? And times because that's going to be 1 is the value. So it's h over 2 times the quantity 1 minus the cosine. And of course, back then, yeah, okay. I want to take B20 minus B, okay, yeah. So I go this guy minus him again, but we want to go F4. And then divided by, I think I needed to have an additional parentheses in front of that. There you go. Yep. I'm not paying attention to my own directions. And then divided by B38, right? So it's going to go all the way down to the span right here. And is that a $sign on that? Yes, it is. $, boom, F4. And then minus B20, boom. And that's also $. Or F4 on both of them. And then boom. And that's going to be multiplied by pi, because you can see that the pi right in there. So what we've done is really taken a ratio of the angle over the span. So you can see that the B span is going to be from 90 to 180. So that's what that thing is on the bottom right here. And this theta, this is just doing increments from 90. So everything greater than 90. And then we want to multiply this by pi. And then close parentheses, close parentheses. And I think that's enough. Right? So let me drag this down to 180. And sure enough, check it out, right? We have our sine wave that's been placed in right here, right? So, and then a similar thing that we're going to need to do when we go to the fall, right? So I can even, if I wanted to, copy down my 180 right here. Let me copy this 180 down, so I don't have to copy everything inside it. But note that some of the things that are going to have to change. So we want to put that at the 270, right? Boom. But in order for this to fall correctly, it's going to need to be a positive value right here, I believe. Plus, and let's see. All right, so 1 second, I got to pause this. I got a phone call coming in. Okay, so back where we were, we want to make this drop down, right? But we need to notice that we were hard referencing these points right there. So we went from 90. So we went from this 180 to 90. We need to change the span. So the span now, we're going to take that 180, and we should probably have entered this in right here. But we're going to bring it down to 360, and we'll do it again with this 180 and bring it down to 360. And then we also are referencing this 90 right here. And I believe that should be to the 270 now. And then this 90 should also be at the 270. And it should equal 1, but it doesn't. Let me see. Should that be a minus? Let me double check. Yeah. Let me see if this works. No, it does not work. All right, so pause the video again and figure out what the hell you did wrong. Okay, so here's what happened. When I shifted this one down, right, so this variable right here, you see that B74? It should be right here. Okay, so that's what we've done. That is the other ones. This is going to take Let me see if I double check that. The B56 right here, and I'm going to subtract from it that 360, yep, and then it's going to divide that by the span. Let's see if that's going to give me the correct value. I get 1, and that will drop me down, okay? And so let's take a look and see what we have here. And sure enough, right there, okay, so we have, now we have used a sine wave to create the position, and we can see that our velocity has jumped like that, and we have, you can see our acceleration now has this discontinuous. It is a jump right here. If we were to make the things a much finer piece, we would a finer increment, we would be able to see that, and we can also see how we have these asymptotic looking kind of slopes going on here where it goes to infinity. So how are we doing in time? It's a 30-minute video. Okay, so now we're going to go and do this to the junior, and we will copy this and move it after the sophomore. And let's see what happens here, right? So what we're going to do for here is we're, instead of the equations that we had before, right here, okay, so we're starting off in position. We're now going to have, let me see if I can move these into place in the junior, right? So I'm going to copy this and bring it over just so I can read it. And I will paste it as a enhanced meta file. You guys don't need to do that because you could just copy and paste it from the PDF, but I had it in Word. So the junior approach, we want to have this. Yes, we're going to have this formula right here. So right here is where it needs to be. So we're going to have theta divided by the span, and we're not going to have that 0.5 right there. So that 0.5 goes away, and where we have 1 right here instead, we're going to have whatever that angle is divided by the span, right? So once again, we're going to need to divide this with an F4, and minus this with an F4. Okay, so now right here we have that ratio. The H we have, we could put a 1 in there just to represent that's the height of the thing. If maybe if we wanted to change it, we could make that a cell somewhere that we could reference. Now we want to subtract out 1 divided by 2, and then I'll use divide again, and then pi. All right. And I think that's true. Okay. And we're going to multiply. And now instead of a cosine, we need a sine. Whoops. And inside the sine, we need 2 pi. Whereas we had just a single pi before. We'll put it over here. 2 times. And I think everything else is the same. So let me see if I have that. Oh, I didn't. I have too many of something. Let's see, what did I do wrong? I have something in here where I have too many of them. I must have left out a parentheses, but it seems to have worked. But I did jump up to 1. So let me pause and see what I did wrong. Okay, I found where I made the mistake. Up here in the numerator right here, this should have been, because I wanted to have in this equation that theta needed not just to be 90, but it needed to be 90, that 90 minus the span, like up here to 180. I'm a little nervous that I don't see these other things in there. Okay, there you go. And that should have been with an F4 right in there. Okay, so here is, I'll double check some of these other things. Minus, that should be fine. Let's see. I should not get a -1. All right, so I have something wrong here. This is such a great video. So I put the 2 right in there. I put a parentheses in here. Why is that parentheses right there? 2 pi. There's no. Okay, that was a useless parentheses. Didn't need to be there. Sine, and I put the 2 over here, but that should not matter. Here it is. This guy right here, I should not have done that. Okay, this should be B20. All right, so what I did, okay, so what I'm doing here is I'm in this cell right here, or it's easier to see in this cell right in there, right, is I am starting to count from 90 over. So that's why that's right there. So that's why it needs to be there. So here I have the correct cell, and I can bring him over. And 1 second here. Yeah, I think this is going to be correct. So let me take a look. Yep. So now you can see. No, don't move him. Let me move this guy out of the way. Move this text box out of the way. Now you can see how smoothly the velocity is making that transition right there. And you can see that this is a sine wave. So that's actually what that equation was doing in the S, was making it there. And now you can see how this is not quite as bad of a jerky thing going on, and it is jerk. Okay, now we need to do the same thing down here for this transition. Let's see, what's the best way to try to do this? I'm going to try to adapt this equation right here. You have to excuse me. You don't have to excuse me. I haven't done this in a number of years. Okay, so that right there is going to need to reference 270. Okay, yeah, I should have actually maybe pulled that thing over here. You know what? Instead of referencing that one, let's reference this first one at 90. That's going to be a better one to use. And we'll come down here and start right here. No, start right here at 270, and I'll plot that in. Right, and so this guy at 180, everybody here should move to 360. All right, and I know this is like everything at 180 should have been moved. Now everything at 90 should have been moved to 270. Oh, damn it. Where did that go? It was at 270. We need to move this down. To 90. This is a terrible video. Oh, come on. How many do we have? How many do I have of these? That's a lot. Okay. And I bet this doesn't come out the way I want it to, but I do. Okay, what I end up doing is I go 1 minus all of that. And let me put that down here. Okay, so okay, this was the sophomore one. I accidentally deleted this guy right here, which was the junior one, and the explanation. So let me go back in here and try to walk through why that worked, right? Why that was supposed to be the way it was. And we go for the solid fill and walking right here. So this is the cell we're talking about that we're moving. And so what we've done, let's even make this even bigger. Well, it's actually, let me see. You need to see this over here. This is going to be 1 minus, and oh, by the way, they actually do walk through that whole thing in the instructions. So you could have just followed along. We could have just followed along with that. Or, by the way, what you could also do is just copy and paste that thing into there. But let's see. We're talking about this cell right here at C56, and we've taken 1 minus. All right, so 1 minus, and then I put a 1 right here to represent that H. The ratio of theta over B, where theta, but we're going to want to start counting here at theta. So we're going to have the cell B56 is the starting off point, and we're going to subtract it, but we have the dollar signs. So we're always subtracting it. So that represents beta. It's going to be divided by the span, which is going to be from B74, that's the last one, minus B56. So that's definitely the span. Now from that, right, minus 1 over 2 over pi, right, times the sine of, well, I put it over here, 2 pi, and then it's going to be the angle again. And of course, we always want it to be a refresh angle, right? We want to start from 0, so we subtract out 270 from 270 to start for this begins 0, but then the next one's going to be 275 minus 270, so that's going to be that theta, and then divided again by the span. So that's the idea, and that's why it works. And we can come back up to here, and we can see that the same thing is going to happen over here towards the end. And if we want to fix these end points, what we can do, by the way, let's copy these always to the end right here. We could take this point right here, and instead of taking that reference, we could make it move this 1 cell up. And the same thing true here. Instead of taking that, it's going to make a slight difference, but it's definitely going to close the thing off. It's going to give it a nice neat look at the end right there. Yeah, it didn't quite work. This really should be going to 0, but you get the idea. And the video was 43 minutes long. So damn, I'm going to leave off here, upload this, and then continue with how to make the profile.